I'm just going to step you through the bisection method for finding roots to an equation. So if you look at this graph, we have the graph of cosine of x minus x, and there is a root you can see from the blue curve right at about somewhere close to 0.7 something. So we're going to use the bisection method to approximate the root. So the first step is to choose an interval. So I've chosen an interval from a to b, and you can see the rectangle which is drawn there. There's a root contained within that rectangle. The top left corner is the function evaluated at the point A, and the bottom right corner is the function evaluated at B. And the way the bisection method works is we bisect this interval from A to B, and we set that equal to C. Okay, so what's so special about C? Well, we use C as a guess to the root. Well, from this picture, I mean, it's not all that close to the root, but it's better than either A or B. And if you look at the interval from C to B, the root is contained in that interval. So we update our interval to from A to B, and we set A equal to C, and we define a new interval from C to B. And a good way to test this is to actually compute the function evaluated at B times the function evaluated at C. If it's less than 0, that means that f of A and f of C have different signs. So the function must have crossed the x-axis. So if f of b times f of c is less than 0, you update our left endpoint, A, and you set A equal to c. And we define a new interval. And then we do the same thing again. We find the midpoint, and we test where the function changes sign. So here, we want to update the right endpoint, B, to C, just like this. And we repeat. We define the midpoint, C, and you notice every time we find a new midpoint, we get closer and closer to the root. And we keep applying the same tests. We evaluate the function at C and multiply it by the function evaluated at one of the endpoints. And wherever that is less than 0, we have to update the interval accordingly. So I update, in this case, A equals C to form that interval. And the midpoint now is to the left of the root, so we update A again to equal C. And now, if we choose a midpoint, you'll note that C is to the right of the interval, so now we update B to equal C, and so on. And we can keep doing this and doing this. And you notice that the interval gets smaller and smaller, and eventually what happens is we get close enough to our root. And by close enough is usually some tolerance which we define before we start running our program. In this case, it's my tolerance is 5 times 10 to the minus 5. But here we have a root. This thing converged to 0.7391 plus or minus 5 times 10 to the 5. And that's the bisection method for finding roots to an equation.